Hi students, it's Ms. Cohen. As promised, here I am. It's Tuesday night and I'm spending it making you a video. Um, this is how your table of contents should look for today, today's date, and the topic. It's lesson 1-8, functions to tables to graphs. And I don't know what page it'll be on, but for me it's on page 9, so I'll put page 9 there. And while you're getting this down, just a couple things. I hope that you've already turned in your pattern project. So you may not work on it in class today. It was due today, so please make sure that gets turned in. And then the other thing I want to say is the nice thing about these videos is that you can pause them whenever you want to. If I'm going too fast, you can rewind and rewatch things. So this video is a tool for you, but you are responsible for knowing this content next class because I don't have time to reteach it. So hopefully the class is quiet and everybody is focused. If not, please encourage your classmates to shush because you need to learn this stuff. So just really quickly, you'll have time later, either later today or next class, to get your notebook in really good shape. But just briefly, and again, feel free to pause whenever you need to, but this was our first lesson. This was the date, topic, and essential question. And these were the notes. And all of these notes pages are on the bulletin board. So if you need them, you can grab them either now or later, whatever is going to work for you. And so that was on page 3 for me. The second lesson was that we took notes on anyway was 1-5, and the notes look like this. It's function rule stuff. The third thing we took notes on was discrete and continuous functions, which looks like this. And then finally, today's notes. This is Unit 1, Lesson 8. So go ahead and pause the video right now so that you can get all of this copied down. We'll take notes in here. You can get them glued. Do remember to leave space on the side because you are going to be responsible for writing at least one question for each lesson and a summary. And I'll kind of smush the summary part down at the bottom. So pause, get this down, and then when you're ready, press play. Welcome back. Okay, today we're talking about graphs, but separated from story problems. And funny enough, it's actually easier to make graphs and tables when we're dealing with a pattern or a story problem or something concrete when there we go. When all we have to work with are letters and numbers, it can be kind of overwhelming. But this says, remember, graphs, tables, and function rules are all different ways to show the exact same thing. So we've been working on those multiple representations a lot with your patterns, but it's true even when there's no pattern involved. You can evaluate functions easily sometimes by just looking at the graph. So I'm going to do 2 examples with you and then you'll try 2 on your own. It says find f of -1. So please write that what I'm asking for is if the input is -1, what's the output? That's what this means, okay? F of -1 means what's the output if the input is -1, and f of 2. Okay, so 2 inputs, we're going to list what the outputs are for each function that's graphed. So here's this complicated function, f of x equals -1/2 x squared minus x, but who cares? I could, of course, plug in -1 in where x is and type it into a calculator. Super complicated, totally unnecessary because we have a graph of the function. And the graph shows all of the input-output pairs for x and y, at least that are visible on the graph. So f of -1 means look for your input, which is x, of -1. And then whatever y is, that's what our answer is. So this is our x-axis. So I'm going to travel along my x-axis to the -1. And then I'm going to search straight up and down. Where's my graph? Where's my graph? Where's my graph? Oh, boom, there it is. Okay, so you go straight down from your input or up until you find the graph that you're looking for. And if it's a function, that's only going to happen once, right? It can't happen more than once if it's a function. This looks like it's about at -2, so I'm going to put -2, right? That's the output. Then it's asking for f of 2. So again, I could plug a 2 in here, but graphs show the same thing and it's a little easier. So this time I want to know when x is 2, what is y? So I start here, I travel along the x-axis, 1, 2, and then where's my graph? Where's my graph? You go up and down, boom, it's right there. it also happens to be a -2. So this is the point 2, -2. When the input is 2, the output is -2. So that's how to do that. I think I'll do one more with you and then have you do the rest on your own. So let's look down at this function here. This is called a sine function, and you won't learn about this kind of function until, I think, maybe Algebra 2, maybe pre-calculus, but it's fun. It makes this little wavy pattern. You have no idea at this point how to even type this into a calculator, so we're going to need to use the graph. This means if x is -1, what is y? So we look. We come to our graph. We go to x equals -1. Remember, this is our x-axis. So there we go. And we go, where's our graph? Where's our graph? Boom. And so that's a little tricky because it's like, what is it? Between 0 and 1, but really close to 1. It is positive. So I'm going to go approximately 0.9. And that's just my best guess. And then f of 2. Same process. So we come up here, we go to x is 2, there's our input. Where's our output? Where's our output? Oh, there it is. That's between 0 and -1, but very close to -1. So this is approximately equal to -0.9. I should say that it's a total coincidence that these were similar. It won't always happen that way. So in these other two examples, these numbers won't really be the same. So what I want you to do right now, you're sort of on the honor system, but do it anyway because it's good for your brain. Pause the video. Do these two examples on your own, and then when you press play, I will show you the answers and you can check them and see if you're right. So right now, 3, 2, 1, pause. Welcome back. So for this example here, f of -1, we go to -1. Where's our graph? There it is at 3. Okay. If you got that, put a little smiley face next to it on your paper. F of 2, when x is 2, I don't have to go searching for the graph. It's right there, and so it's at 0. It's not up, it's not down, it's at 0. If you got that right, smiley face. Down here, f of x equals -x minus 2. I hope you realize this is a linear function. The others are functions, but they're not linear. This one's linear. F of -1, there's -1. Where's my graph? There it is. It's down 1 at -1. And then f of 2 is -4. Okay, because it's down to the -4. Okay, that's it. Open this up. So to create graphs and tables from function rules, this is a different topic. Step 1 is to choose numbers for the domain. So those are your x's. I don't want to, you can read this over on your own. Step 2 is evaluate the function. Circle, plug it in. There used to be this commercial for Glade plugins that went, plug it in, plug it in. Anyway, that's what I always think of. Okay. So we have to make sure we know our order of operations so we can do this. And this is on the poster in the front of my classroom, but let's go over them. You know probably PEMDAS. I do it a little bit differently. Instead of PEM or P, I use G. And G just stands for grouping symbols. So you might want to write that down, grouping symbols. There are lots of different grouping symbols. Parentheses are just the ones we see most often, but there are a lot of different kinds of grouping symbols, and we'll talk about them more later. And then, so in PEMDAS, it's PE for exponents. So this is step 1, step 2. And exponents are these numbers that are little and up high. And so I want to take a quick moment and talk to you about exponents because you're going to have to do this on your work today. If you have something like 4 to the 3rd power, this is called the base and this is the exponent, and that just means 4 times itself 3 times. I am noticing, at least in my other algebra class, that students are not knowing how to type these into the calculator. You obviously know how to type in 4 times 4 times 4, but sometimes you have a problem like 4 to the -1st power, and you have not learned how to do that by hand. And so you need to know how to type exponents on your calculator. So if you don't have a calculator with you at the moment, that's okay. I'll just show you and we'll write it down. You type in your base, so you would type in a 4. And then this button right here, I'm circling it, that little like upside down V, that's your exponent button. And so I want to hit that, and the next number I type is the exponent. So if I'm doing 4 to the negative first power, I would then type in a -1. BT dubs, that's your negative button, that's your minus. So if you're doing a negative, you have to use this. If you use this, it'll totally mess you up, okay? So 4 to the negative first power equals 0.25, which is a little surprising, okay? And just to type, you do 4, then you do this button, then you do this button. Whoops, oh no. This button, that's the negative button, and then the 1. Okay, so back over here, along with exponents are roots, like square roots. We'll talk about those later, but that happens in the same step. Then MD for multiplication and division, that's step 3. And then AS for addition and subtraction, so GERMDAS. Okay, and then the other thing we have to know before we can do this skill is how to plot an ordered pair. So XY is the same as XF of X. We have an input and an output, an input and an output. X is, okay, that's your x-axis, and it tells us left or right. So if X is positive, we go to the right. If X is negative, we go to the left. Okay, starting from the origin. We'll practice this in a minute. So that's X. Y is the up-down axis. So if Y is positive, we go up. If Y is negative, we go down. You need to be totally secure on this. It comes up pretty much every day for the rest of your life. So we'll practice it today. We have 2 examples to do, and then you are on your own. So example 2. It says graph f of x equals 3x minus 5, and then it gives you a domain. So it says D, -1, 0, 1, and 2. That means use this as your inputs. And so we're going to take these numbers and put them in the input column. So -1, 0, 1, and 2. And then we plug in, and we plug into this part of our function rule, okay? This 3x, by the way, means 3 times x. And so what we're going to be doing is we're going to do 3 times our input minus 5. And we're going to do that 4 different times. 3 times our input, take away 5. That's going to give us an output. And once we have an input-output pair, we can graph it, okay? So the way I want you to set this up is we're going to do 3, I'm going to use parentheses for the multiplication. 3 times our input, take away 5. 3 times our input, take away 5. Remember, I said we were going to do this 4 times. And feel free to pause if I'm going too fast. Okay. The only thing that's changing as I go down is the number of my input. So in this top row, my input is -1. Then my input is 0 here. Then my input is 1. And then my input is 2. Okay. So I've taken this rule, I've written it 4 times, only replacing x with whatever the input is. Honestly, for some of these, you're better off just doing them in your head. We need to make sure we've got multiplication and subtraction. And so looking over here, we need to make sure that we do multiplication before we subtract. But like this bottom row is super easy. 3 times 2 is 6. 6 minus 5 is 1. But they get a little harder because 3 times 1 is 3, take away 5. We're going into the negatives. It's awesome if you can do that in your head. But if you don't feel confident, turn to your calculator. So at this point, you all, if you have not grabbed a calculator, please do. I do not want you using your phones. And it's not just because I don't want your phones out. It's because the phone calculator is different from this calculator, and you don't get to use your phones on the test. You have to know how to use these, and there are some tricky things to it. So 3 times 1 minus 5, I'm going to type it in exactly the way I have written it out with parentheses and everything, because your calculator knows that the parentheses mean times. Now, minus. Do not use this. This is negative. If you're subtracting, you have to use this button. So -5. If you use the negative, you'll get the wrong answer, okay? So 3 times 1 minus 5 is -2, and so that'll be our output. Will you please pause the video, and I want you to type this in, write your answer, type this in, write your answer, and then check back in to see if you got it right. Okay. So 3 times 0 is 0, and 0 minus 5 is -5. So I'll do that one in my head. This one I'm going to type to make sure you know how to type it correctly. So 3 times -1, you must use this for negative. Okay, so 3 times -1, and then for the minus, you have to use the minus button. Make sure you do that right. -8. All right. So now that I've done that, this is just calculator work. I have these 4 input-output pairs, and I need to graph them. And so, I don't have a straight edge with me. I'm going to have to use a piece of paper. So I'm going to do a y-axis, sort of in the middle here. You can do the same thing. I'll give you a second. I'm opening a new package with protractors. Hold on. Okay. Now, for the x-axis, I'm going to be a little strategic. I want to be able to get all the way down to -8. So I'm going to put mine a little bit above the middle, just because I know that way I'll get everything to fit. Oops, that's x. Okay. So let's graph it. We've got an input, output. So when the input is -1, I'm going over this slowly, guys, because my other algebra class struggled so much with this graphing. So forgive me if I'm going too slow. X of -1 means from the origin, we're going to go 1 to the left because this is the negative side. So you can kind of write negative, positive, and this is negative, positive. Okay. So we're going to go left 1 from the origin. So you put your pencil here, you go 1 to the left, don't make a mark yet, because our output, -8, tells us how far up and down to go. And because it's negative, we're going down. So from the origin, again, we go 1 to the left, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Make sure you're counting lines, not squares, okay? So from here, this is like 0. 1, 2, 3, 4, 5, 6, 7, 8. That's where it goes. 0 means we go left and right 0, which basically means I just start right there. The -5 means I go down 5. 1, 2, 3, 4, 5. Big point. Okay, down 5. I have another input-output pair. This is positive in the x direction. So that means I'm going to go 1 to the right. This is still negative. I'm going down 2. So from the origin, 1 to the right, 2 down, 1, 2, big point. And the last one, 2, 1. This is positive, so I'm going 2 to the right. And this is positive. So think about which way we're going. Up 1. So from here we go 1, 2, 1. All right. This is a linear function, and so you can see that the points do form a line. Because we're graphing an entire function and it's not related to a story problem, you don't have to worry about whether it's discrete. If you're given an equation like this, you always will connect the points with a line. So extend your line all the way out the grid. We just took a function rule. We had 4 inputs to create 4 input-output pairs. We plotted those 4 points, we connected them. So that's the process. We'll do one more together. Though I will say, if you feel extra confident about being able to do this on your own, feel free to fast forward, well, pause it, do the exercise on your own, and then fast forward to see if you got it right. But if you'd like to go slow with me, go slow with me. This problem is a little different because it didn't give you any numbers in the domain, and when that happens, it means you get to choose what numbers to put. I generally recommend putting 0 in the middle and then going up and going backwards. So I'm going to go, I think I might count, let me think. No, I'll just go 1, 2, negative 1, negative 2. Okay, so we're just going up by ones with 0 in the middle. And this way you can kind of see what's happening both on the negative and positive side of your graph. So our next step is to plug everything in. This function rule is x times itself minus 4. So you're going to have the same number in both of these spots, whatever your input is. So another way to think about it is this is the input times the input, take away 4. Okay. In the top row, my input is negative 2. So I'm going to, again, use parentheses for the multiplication. Okay. And my input is negative 2. So negative 2, and there's little invisible times there, times negative 2, take away 4. So go ahead through your whole table and just plug in. I'll do it with you, but I'll stop talking. If you still need time, go ahead and pause, but this is what it should look like. So we're just taking our input, plugging it in into both input spots. I can definitely do these in my head. These are pretty easy. We do need to make sure we multiply before we subtract. I'll start at the bottom because everything's nice and positive. 2 times 2 is 4. 4 take away 4 is 0. 1 times 1 is 1. 1 take away 4. See if you have 1 positive and then you go 4 toward the negative direction. That's negative 3. If you're not confident with your positives and negatives, please don't worry. That's why we have calculators. You just type it in exactly the way you see it. Make sure to use minus and not negative. And there you go. Okay. 0 times 0. This looks like boobs to me. 0 times 0 is 0. Minus 4 is negative 4. And then here, be really careful. I hope you know that a negative times a negative equals a positive. So this is going to give us positive 1, take away 4, which we already did, right? Negative 3. But again, if you're unsure, come over here. Negative 1 times negative 1, take away 4. Again, I know I keep saying it. Just make sure this is a negative sign and that's a minus sign, right? But it will give you negative 3. And then here we have negative 2, times negative 2, take away 4, gives us 0. So there's sort of an interesting thing happening here, and I hope you can see this is not going to be linear. I'm going to go ahead and set up my graph. And by the way, I'm not numbering my axes, and you can do that as long as you intend to count by ones. So if you're going to count by anything other than ones, you have to show that by numbering. All right. Again, feel free to fast forward if you think you can do this on your own, but otherwise stick with me. If the input is negative 2, that means I'm going 2 to the left, and then I'm going up and down 0. So that's going to look like this. We start here, we go 1, 2, and then we don't go up and down. There's our point. Negative x means we're going to the left, so we're going to go left 1, down 3. Left 1, down 3. 0 means we'll go left and right 0, not going to move at all. And this is negative, so we'll go down 4. 1, 2, 3, 4. Okay. This is positive 1, so we're moving to the right 1. Negative, so down 3. Right 1, down 3. Remember to pause if I'm going too fast. Positive 2 means 2 to the right, up and down 0. 2 to the right, boom. This is a quadratic function. It makes this nice little U, and so if you want to, you can connect them with a nice curved U. You don't have to, but it's kind of nice. So that's it. This is a lot. This video is kind of long, I know, so thank you for sticking with me. This is what should happen for the rest of class. The first thing I want you working on is this guy. Okay. So Mr. Smith should hand this to you. It's a bunch of practice of what we just did, plus some review for the test built into it. So I'm hoping that you can get this done in class today and get it turned in. If for some reason you don't get it done, you can take it home, but that is not a reason to goof off in class. You're going to have more success if you do it in class while this is fresh and while you have your friends around to help you. So get this done. If you do finish with this, then you can work on the homework packet because pages 1 through all of them are due next class. So again, I wrote this down. Due next class. This worksheet and the entire homework packet. I'm going to be collecting the homework packet next class and getting it into the grade book. So no more credit will be given after that. Okay, hopefully you like this video. Feel free to subscribe to my YouTube channel. Work hard.